So to differentiate between experimental probability and theoretical probability, for experimental probability, for example, if you toss the coin 20 times and you have 13 heads and 7 tails, probability of head according to this experiment equals what? Toss the coin 20 times in all. You toss the coin 20 times. Now you have 13 head and 7 tails. So probability of head 13 over 20. Probability of tail 7 over 20. Okay. But theoretically we know that probability of head equals 1 over 2 and the probability of tail also 1 over 2. Am I right? Because we have two faces. We have one face head and one face tail. So probability of head 1 over 2 and the probability of tail 1 over 2. So why they are different? Because we don't have enough number of trials. If you toss a coin about 1,000, so the probability of head will be closer to 1 over 2. So if you toss the coin 1 million, so the probability of head will be very close to 1 over 2. So if you have enough number of trials, so the theoretical or the experimental one will be closer to theoretical one. Okay? So the theoretical or the experimental will be closer to the theoretical one if you have enough number of trials. So for example, imagine that if you toss the coin 100 million times, so about 50% of them head and 50% of them tail. This is approximately. So if you have enough number of trials, the experimental one will be closer to theoretical one. But if you have a few number of trials, they will be different. Understood? If you increase the number of trials, the theoretical, the experimental will be closer to theoretical. Okay? Understood? The difference between experimental and theoretical. Number 1. Read number 1, Talim. Faulty items. Okay. This is the number of the items produced. This is the number of the faulty items. This is the experimental probability. To find the experimental probability, you need to find the number of the faulty ones over the total numbers. For the first one is done for you. So the experimental probability, number of faulty ones, which is 8 over 100, so 0.08. Can you complete the table now? Yes. Okay. So to find the experimental probability for the second line, 20 divide by 200, then 45 divide by 500, then 82 over 1000. This means if you have sample 100, you have 80 faulty ones. If you have sample of 200, now you have 20 faulty ones. If you have sample of 500, you have 45. If you have sample of 1000, you have 82. Now find the experimental probability for each sample. Did you complete the table? 20 divided by 200, 0.1. Okay. Then 45 divided by 500, 0.09. 82 divided by 1000, 0.082. Which is the best estimate of the probability of an item being faulty? Explain your answer. Look, we have the probability of the faulty 0.08, 0.1, 0.09, 0.82. Which one is the best estimate for the probability of the faulty ones? I told you if we increase the number of trials, if we increase the sample, then the probability will be close to what we need. Okay? So now if you have sample of 100, and you have 80, If you increase the sample to 200, now you have 20. Now if you have sample of 500, 45, and then you get the probability or the experimental probability for each case. Now if you have the sample of 1000, now you have 82. So the greatest number of trials give you the best estimate for the probability. The greatest number of trials give you the best estimate for the probability. For B, which is the best estimate for the probability of an item being faulty? The 0.082, because this corresponding to number of items 1000, and if you increase the number of items, you get the best estimate for the probability of the faulty ones.
Beth rolls a six-sided dice.
Speak up.
20 times.
Okay.
Beth rolls a six-sided dice 120 times. The results are shown in the table.
How could, oh
How
yes,
could Beth obtain an accurate estimate of the probability of scoring 2?
okay. Now number of dice, listen. We score the number of dice 100 times. We get 1, how many times? 18 times. 2, 25 times. 3, 20 times. 4, 22 times. 5, 14 times. 6, 21 times. So to find the probability of getting 2, how many times did you get 2?
25.
And the total number?
120.
So to find the probability of getting 2, 25?
over 120.
Yes, you are right. Good job. So for A, probability of scoring 2, the number of times you get 2, which is 25, over the total number, which is 120. You don't need to simplify, you can leave the answer. Understood number A? Understood A? For B, Lama, can you read B? If the dice,
If the dice is rolled 1,000 times, how many times would you expect to get a score of 2?
okay. This for 100 times, 25. Now for 1000 times, you can predict from the probability. From this experiment, you can predict. If you rolled 100 times, 1000 times, how many 2s do you expect? Do you remember when you watch the video for the school? We have 600. We multiply the total number by the probability. Now you have the probability. You have the probability 25 over 120. So multiply this probability by the total. Multiply this probability by the total number, which is 1000. Okay? So 1000, this is the total number. Okay? Multiply the probability of getting 2 or scoring 2. 25 over 120. So to find the expected number, multiply the total number of times, multiply by the probability.
20.83.
20?
0.82.
20, boy, 20 what?
20.
208. Said 208.
200? Exact?
0.83.
208.3, then round down, so 208. If the dice is a fair dice means the probability of getting 2 equal probability of getting 1 equal probability of any one. Okay? Probability of getting 1 equal probability of getting 2 equal probability of getting 3, same. Which is 1 over 6. Okay? Because for the dice we have 6 faces. So probability of getting 2, 1 over 6. Probability of getting 1, 1 over 6. Probability of getting 5, 1 over 6. Now if you have fair dice, how many times would you expect it to land on 2 after 1000 times? Now in this case, if we consider this fair dice, so multiply 1000 by the probability of getting 2, the theoretical probability of getting 2, which is 1 over 6. Okay? So what is the answer? 1000 times 1 over 6. 1000 times 1 over 6. 166.6, so round up, so 167. For number 3, read number 3, Horia.
Parts from the spinner are shown in the diagram. The relative frequency of the number of times the spinner lands on red are shown in the table.
Relative frequency, this means experimental probability. Okay? Same. Relative frequency, this means the probability, the experimental probability. Go ahead.
Plot the relative frequencies on a graph.
Okay. So this is the number of spins. This is the relative frequency of the experimental probability. For 10 times, the probability 0.3, 20 times 0.25, 50 times 0.28, 75 times 0.24, 100 times 0.26. We don't need to solve A, so cancel A. Now for B, write down the best estimate of the number of times the spinner would land on the red in 1000 spins. So what is the best estimate? We agree that if we increase the number of trials, we get the best estimate. So we have 10 times, 20 times, 30, 50 times, 75 times, 100 times. So we can get the best estimate if you increase the number of trials. So 100 will give you the best estimate for the probability. So the best estimate for the probability equals what? 0.26. Okay? 0.26. So the answer for B, 0. Write down the best estimate for the number of times would you land. Okay. Now I need to find the number of times. So 0.26, this is the experimental probability. Now we need to find the number of times if you spin this 1,000 times. So multiply 0.26 but by 1,000 equals 260. 260. So to find the number of times, to find the expected number, multiply the probability times the total number. But why we chose this probability, not this one, not that one? Because this is the best estimate for the probability. So multiply the best estimate for the probability by the total number of spins to find the expected number, or the number of times the spinner would land on the red one. Understood? For C, do you think the spinner is fair? Is it fair or unfair? Why fair or not unfair? Explain. Answer. How many red do you have? How many red section you have? And what about the total? We have 6 in all. So 2/6, which is 1/3. Okay? So we have 1/3 of the sections are red. So we expect that 1/3 of 1,000 will be red. Am I right? If you spin 1,000 times, because the red section about 1/3. So this means 1/3 multiply 1,000 theoretically. 1/3 multiply 1,000 about 333. 260 closer to 333 or not close? Not close. 260, 333 are not close. Close if, for example, 325, 320, we can say that's close. So we cannot say that the spinner is fair. This is not fair. This is unfair. Because if it is fair, the number of times will land on the red section should be closer to 333. Because we have 1/3 of the sections are red. So we expect that 1/3 of 1,000 will be red. 1/3 multiply 1,000 about 333. This number not close to 333. So we cannot say that this is fair. So no, it's not fair. Done? Not fair because we have 2 red sections. And we have in all six sections, okay? So 1/3 of the sections are red. And if you spin 1,000 times, so you expect that 1/3, 1,000, about 333. But the actual, the best estimate, 260. 260 not close to 333. So C, we can answer C after we find the answer from B. From B, we have 260 times. In 1,000 spins, we have 260. The expected number for red, 260. But theoretically, it should be 333. So this number not close to that one. So the spinner is not fair.
Max spins a four-sided spinner 100 times. Here are his results. What is the estimated probability of a score of 4?
Okay. What is the estimated probability of a score of 4? We have 100 times. 1 appears 20 times. 2 appears 25 times. 3 appears 23 times. Or the spinner land on 1 20 times, on 2 25 times, on 3 23 times, on 4 32 times. So the estimated probability of a score 4 equals what? To find the probability of getting 4, number of times you get 4 over the total number. Number of times you get 4, 32. The total number of times, 100. So 32 over 100. Understood? So the probability, the number of times you get 4, which is 32, over the total number of times, 100. So A equals 32 over 100. Understood, A? B. Go ahead, Rinat.
Do you think the spinner is biased? Give a reason for your answer.
Okay. For this spinner, we have 4 sections. Okay? 1, 2, 3, 4. We have 4 sections. 1 appears 20 times from 100. 2, 25 times. 3, 23 times. 4, 32 times. Do you think this spinner is biased or fair? Sorry? Yes. Look, probability of getting 1, 20 over 100. Getting 2, 25 over 100. Getting 3, 23 over 100. Getting 4, 32 over 100. So, this spinner is biased or fair? How do you know if it's fair or... Look, for example, if you have coin and you throw this coin 100 times. If you get, for example, 70 head and 30 tails, so can you say that this coin is fair?
No.
70 head and 30 tails. So we cannot say that this coin is fair. Okay? But if we get, for example, about 55 head and 45 tail, so can we say that this is fair? The coin? Yes, because it's closer to 50. About 50% for head and 50% for tail. So now this spinner, we have 4 sections for this spinner. So if the spinner fair, okay, the probability for each one of them, divide 1 by 4, so 0.25 for this one, 0.25 for this one, closer to 0.25. Now the probability for each one, or you can say that we have 100 times, 100 divided by 4 equal 25. So if this number closer to 25 and each number closer to 25, this means we have fair spinner. If the number of times will be the same for all, because we have 4 sections. If it is fair spinner, so 100 divided by 4, 25. So if this number, if each number closer to 25, so we can say that this is fair. Closer, not exactly. So we have 20, 25, 23, 32. So can you say this closer to 25 or not close? If you say that yes, this is fair because all of the numbers are closer to 25, I'll accept this answer. Okay? But if you say that probability of getting 4, 32 over 100, and the probability of getting 1, 20 over 100, so they are not close to each other, so this is not fair or biased one, I'll accept this answer. So this about your explanation for the question. So you can say that fair and give a reason for that, or you can say that this is not fair, but give me explanation why you say that this is not fair. Okay? So I'll accept 2 answers for this question. If you say that this is fair, Just give a reason why this is fair. You can say that, yes, all the numbers are closer to 25, or the probability for each one closer to 0.25. So I'll accept this answer. But if you say, no, 20 and 32, they are not closer to 25. We have 20 and 32, the difference between them 12. So probability of getting 1 is less than probability of getting 4. So this biased one or not fair. I'll accept that. Okay? Understood? So if you said fair, you should give a reason. Biased, give a reason for that. But the rule, if the probability for each one, if they are equal probability for this one 0.25, closer to 0.5, and this closer to 0.5, and this closer to 0.5, so this, then we can say that this is fair. Understood?
Yes.
Now for C,
Select what.
so you can say that fair because the probability of 1 or the number, because the number of times for each section close to 25. Okay? Now for C, if Max spins the spinner 500 times, how many times would be expect to get a score of 4? Probability of getting 4, we get in A. This is the probability of getting 4. Okay? So for C, the expected number if you spin the spinner 500 times. Yes, multiply. Multiply. To find the expected number, multiply the probability times the total number of times. The total number of times. Probability of getting 4, 32 over 100. If you spin the spinner 500 times, we need to find the expected number, multiply by the total number of the probabilities. So equals, what is the answer? 160. So 160 times. 160 times. So to find the expected number, the probability times the total. Probability times the total to find the expected number. Asil, read number 5.
You see those are growing thin and records the numbers of the times that land points up. Here results are shown in the table. Copy and complete the table for the relative frequency.
Okay. If the number of throws 10, so the number of times lands point up 6 times. So the probability divide the number of times land up over the total number. So 6 divided by 10, 0.6. We need to complete the table. So to find the relative frequency or the probability, divide the number of times it lands up, divide by the total number. So 13 over 20, then find the answer. 20 over 30, 25 over 40. 32 over 50, then complete the table. Okay? So what is the answer for the table? Can you tell me the answer for the table? 0.65? 65 or 64? 0.65? So 0.65, 0.67, you round to, okay, to two decimal places, okay. 24 divided by 40, 32 divided by 50, 0.64. Now, what is the best estimate of the probability of the pin landing point up? Which one? 0.6 or 0.65 or 0.67 or 0.6 or 0.64? Why 0.64? Yes, because this is the number. As we increase the number of times, number of throws, we get the best estimate for the probability. So the best estimate for the probability 0.64. 0.64. So the answer for A 0.64, because if you increase the number of throws, you get the best estimate for the probability. Sorry? This is the answer for B, yes. Because answer of A just complete the table. This B. Now C. How many times would you expect the pin to land point up into 100 throws? Yes. We get the best estimate for the probability to land up. Now if you throw 200 times, how many times you expect to land up? Multiply. The same. To find the expected number, multiply the probability, the best estimate for the probability, which is 0.64, by the total number of times. Equals
128.
128. Is it hard? Number 6. Jomana, can you read number 6?
Ellen has a bag containing yellow and blue cubes. She picks a cube from the bag, records the color, and replaces the cube. She does this 100 times. Her results are shown in the table. Copy and complete the table for the relative frequencies for the number of times a blue cube was chosen.
Okay, so who can complete the table? We have the number of trials, we have the number of times blue cube chosen, then we need to find the relative frequency. To find the relative frequency, you need to divide the number of blue cubes divide by the total number. So 3 divided by 10, 0.3. So Qasim, can you complete the table?
8 divided by 25.
Yes, 8 divided by 25 equals? Use your calculator. Yes, use your calculator and find the answer. 8 divided by 25. Equals? You don't know how to use calculator? Yes, Qasim. 8 divided by 25.
0.32.
Then 15 divide 50. No, give him to.
We first figure out everything.
So equals 15 divided by 50.
0.3.
28 divided by 100. 0.28. Okay. This is the answer for A. Now B. Layan, what is the best estimate of the probability of picking a blue cube from the bag? Why you tell her?
0.28.
Why 0.28?
Because the more the number is increased.
Yes, you are right. Because we have 100 times, so the greatest number of trials give you the best estimate for the probability. As you increase the number of trials, as you get a probability, the best estimate for the probability. So 0.28. So the answer for B, 0.28. Now C, Nurhan, read C.
There are 75 cubes in the bag altogether. What is the best estimate in the number of blue cubes in the bag?
Okay. So to find the expected number, you have 75 cubes in all. I need to find the number of blue. You have the probability of blue. Sorry? The answer is 0.28. You have to multiply the probability by the total number of times, by the number of cubes. The total number of cubes. You have 75 cubes in all. To find the number of blue cubes, multiply the probability of cubes, blue cubes, times the total number. Okay? The expected number equals the probability times the total. So what is the answer? 21. Number 7. Anas, can you read number 7?
records the number of times it lands on heads, and these results are shown in the table.
Okay.
Copy and complete.
So if the number of throws 10, number of head, we have 7 heads.
7 divided by
20, 12, 30, 18, and so on. Copy and complete the table to show the relative frequency of heads. Okay, can you solve A?
12 divided by 20.
Yes, 12 divided by 20,
0.6.
0.6. Then
18 divided by 0.62.
0.6. 22 divided by 40, 0.55. 0.56. Okay, this is the answer for A. Now for C, write down the best estimate for the probability of landing on heads. The best estimate?
0.56.
Okay, so the answer for C, 0.56. D, use your estimate to predict the number of heads in 200 throws.
112.
Yes, Abu Bakr, how do you do?
So we multiply 0.56 by 200. which is
Yes,
gonna give us
multiply the probability by the total number of throws. So 112. 112. Now E. Listen. 0.56 is the best estimate for the probability. Times the number of throws to find the expected number. Now for E. Read Anas.
Do you think the coin is biased towards heads? Explain your answer.
Okay. Do you think the coin is biased? Look, probability of getting head, if you have a fair coin, probability of head should be 0.5. Okay? Closer to 0.5. If it is fair, closer to 0.5. But now we have, look, for this coin, 0.56. So 0.56 is close to 0.5. So I told you if you explain in a proper way, I'll accept that. So we can say, yes, it's biased because 0.56 is not close to 0.5. I'll accept that. Okay? But if someone else said, no, 0.56 is very close to 0.5. So it's fair, not biased. I'll accept that. Okay? So this is according how to explain the reason. Because, yes, so 0.56, I can consider this not close to 0.56. So do you think the coin is biased? Yes, biased. Why? Explain your answer. Because probability of head should be around 0.5. Okay? But 0.56, I can consider 0.56 is not close to 0.5. Because the best estimate for the probability of head 0.56. But we need 0.5. If it is fair, the probability should be 0.5.